So now we're going to do some examples using z-scores and z-tables. I want to quickly go over the steps again, right, before we start working through these problems. So if I have to find an area under our normal curve or proportion or percentile, the first thing I want to do is sketch a problem. You need to draw the quickest normal distribution in the West, right? Then you have to standardize your score by finding a z-score, which is our sample data value minus our mean over the standard deviation. Then once I know my z-score, I can take that to a z-table to find the area under our normal curve. So let's work through an example. So in the last video, we were given these three IQ scores and calculated their z-score, right? We calculated the number of standard deviations they were away from the mean. And what I want us to do now is find what percentile these values mark, right? So I have a z-score of -1, that should be a -1. I had a z-score of 0, and I had a z-score of 1.67. So how am I going to interpret this to figure out what percentile a z-score of -1 marked? Again, we had a normal distribution. We have our mean, which was 100, right? 85 was one standard deviation below the mean. So if we want to find what percentile it marks, we want to find the area to the left of that, which is exactly what we're going to do when we go to our z-table. So let me take you to the next slide. So I had a z-score of -1. Here I've got my negative z-scores. Here I've got my positive. So I'm going to go on my table. I'm going to go to -1.00. See how this is like 0.00? So I get 0.1587, right? That means that the area to the left of 85 is 0.1587. That's the area in the normal curve. So that means 85 marks the, let me round that, the 16th percentile, meaning that 16% of data values are less than 85. Well, let's look at a z-score of 0. Remember, if you have a z-score of 0, that means you're the mean, but let's go to our table and take a look. So here I want to find a 0. Notice I've got -0 and +0. They're both the same. 0 shouldn't be negative. That kind of throws me for a loop. But here at 0, 0, I've got 0.50, and that makes sense, right? Our mean means half the data is below it and half the data is above it. So I could sketch a picture if I wanted. Here's 100, shade it, right? But the area to the left of 100 is 0.50, meaning that 100 marks the 50th percentile. 50% of people score less than 100. It also means the converse, right? 50% of people score more than 100 on an IQ test. Lastly, for 125, we found a z-score of 1.67. So let's go to our z-table and take a look at this. So I'm going to sketch this first, right? I've got 100. Here I've got 125. We know this area is going to be greater than 0.50. So I go to my z-table for 1.67. Okay, so now I have to go to the positive side. I go to 1.6 and then I go to 0.7 and I kind of see where these like intersect. Is that right? 0.9525, right? So that means the area under our curve here is 0.9525. So we could say that 125 marks the, let's round it, 95th percentile, right? So if I have my z-score, I can take it to the z-table and I find the area to the left of the curve.